All right, let's talk about how to solve an equation like this: x cubed minus 64 equals 0. Now, one thing you should realize is we're not just finding the x-intercepts of this graph. If we were just doing that, we'd want to just find the real number answers, and we could add 64 to both sides and take the cube root of both sides. We'd get 4. That's the x-intercept. But we're asked to solve. To solve this means to find all of the answers, the real answers and the imaginary answers. So I'm going to factor it as a difference of cubes. So I have a small set of parentheses here and a large set. I'm going to show you how I got all these numbers here. This place is what you would multiply times itself 3 times to get this. So x times x times x is x cubed. Excuse me. This term is 4 because 4 times 4 times 4 is 64. So 4 cubed is 64. This symbol is a subtraction sign because that one is. If this had been addition, then this would have been also. Once you get this information, then, and all of this came from up here, all of these are going to come from over here, not from up here. So this term is that one squared, that one times itself, so that's x squared. This term is this times this, so that's 4x, not paying any attention to this sign, just this term times that term, so that's 4x. This operation is the opposite of this. So if this had been addition, this would have been addition, and that would have been subtraction. But since this is subtraction, so is this, and this is going to be the opposite of that. So this is addition. And then the last term is just this number times itself. So 4 times 4 is 16. And the last operation is always addition when you do a sum or a difference of cubes. So once I do that, I use the zero product property. In other words, I set this equal to 0 and I get the 4. So 4 is the number that when you put in here, you get 0 there. This, on the other hand, won't factor, so we're going to have to use the quadratic formula. So the a term is 1, the b term is 4, the c term is 16. A is the coefficient of x squared, b is the coefficient of x, and that's the c term there. And I'm substituting this into the quadratic formula. So it's the opposite of b, so the opposite of the b term, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. That's called the quadratic formula. And when I simplify that, I'm going to do 4 squared, which is 16, and then I'm doing negative 4 times 1 times 16, which is negative 64. So it looks like that. When you do the subtraction, it gets you here, and we're going to factor out that negative 1 term there. So that becomes negative 1 times 48. Not negative 48, but negative 1 times 48. And you should know that the square root of negative 1 is I, so I put an I right there. So the square root of negative 1 is, I. So that's where that I came from. And I'm going to do 48 as 16 times 3. Because that'll be the easiest. Everything else stayed the same. And then when I move this up, notice the square root of 16 is 4, and that comes on the outside there, so 4, because the square root of 16 is 4. So that's negative 4 plus or minus 4i, and the square root of 3 is left over, and that's over 2. At this point, I realize I can take a 2 out of this, and this, so I do. 2 goes into 2 one time. So there's nothing underneath here but a 1. So if you're dividing by 1, you don't really have to do it. So notice the 1 kind of disappeared there. 2 goes into negative 4 negative 2 times, and 2 goes into 4i 2 times. So there's my final answer. So I have 3 answers here. I have 4, and then I have negative 2 plus 2i squared root of 3. And then I have negative 2 minus 2i squared root of 3. So there are 3 answers. And that's what we would expect because this is raised to the 3rd power. When you have something raised to the 3rd power, you should have 3 total answers. And we do have in this case. So that's how you solve an equation like that.